Welcome back to section 4.1, page 6. If the given graph is Eulerian, find an Euler circuit in it. If the graph is not Eulerian, first Eulerize it and then find an Euler circuit. Write your answer as a sequence of vertices. There are many possible correct answers. Okay, so the first thing we have to do is decide whether there's already an Euler circuit in it. So the way we're going to go about doing that is figuring out if all the vertices are even, because that will mean it has an Euler circuit. So let's go ahead and add and figure it out. 1, 2, 3, 4. So that one's even. So good so far. 1, 2, 3, 4. Another even one. Here, 1, 2, 3. Oh, just blew it there. We don't have an Euler circuit. 1, 2, 3 here. Okay, so because we have two odd vertices, we do not have an Euler circuit, okay? So it says if it's not Eulerian, first Eulerize it. Okay, so our problem are these two odd vertices, so we want to make them even. So if you recall what they told us to do, they said add another edge. So the easiest way to change this is if we just add an edge, and I'm going to do that, well, maybe black would blend in too well. Let's do here. If we add another edge going from C to D, we now just made that 1, 2, 3, 4, so we can cross that out and put a 4 in. And this one, 1, 2, 3, 4. So that's the easiest way to fix the problem, okay? So now it says, then we're supposed to find an Euler circuit. Okay, so that's what we're going to do, and we're going to list the vertices, and there are many different ways to do this. So remember, all you have to do is start and end at the same spot and cross things just once. So I'm going to go ahead and say, okay, let's start at A. That just makes it easy. And that's going to be, we're going to go this way, and we'll say 1. And then we'll go around the outside, and that's 2. Keep going around the outside, that's 3. Okay, so I'm going to start by writing down. We have A, we did A, B, D, back to A. Okay, kind of keep track of what we're doing there. Okay, then 3. Then I'm going to go here and say 4. And then here I'll say 5. And then how about down here and say 6. And then back up, say 7. And here 8. And we're back to A and we're done and we covered everything. Okay, so if you recall, we went around the outside. Then we need to go here to B. And then here to C. And then down to D, and then up to C, and then over to A. Okay, so that's it. That's all we have to do for that one. So let's move on to the next one. So again, let's count up and see what we've got here. Well, 1, 2, 3. Oh, already off the bat, not going to work. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. Okay, you might recognize this. This is the Königsberg bridge problem. So we know it doesn't have an Euler circuit. We've talked about that over and over. So how are we going to change it? Well, we need to make all of these even. So the easiest way to do it is just to take two odd that are close together and create another edge. So I'm going to take A and C and create an edge here. Okay, so like this. All right. And then I'm going to take B and D and create another edge there. So, well, let's change this. This changes to 4. This changes to 6. Okay, and then when we create an edge here, this changes to 4 and this changes to 4. So, was that the only way to do it? No. We could have added, edges from here to here and then from here to here. There's all sorts of different ways you could do it. This is just the way I'm choosing to do it. Okay, so now if we look at it, we have all evens. Okay, so now that they're all evens, we know we can find an Euler circuit. So I'm going to go around the outside again. I'm going to say 1 and then 2. And then I think I'll go here next, 3, but there's many ways to do it. And then here, actually let's go here, 4. Just trying to not make it too confusing. 4 and then 5 this way. And then we'll go 6 this way. And then we'll go down here 7. And then up here 8. And then up here 9. And we're back to A. So we started at A. So let's go through it again. We went from A to C. And then we went down to D. And then we went back to C. And then we went to A. and then we went to C, and then we went to B, and then we went down to D, back up to B, and back up to A. Okay, so that's how you go about doing it. I want you to try your classwork problem number 16, and then come on back, pause the video for that. All right, so when you do yours here, hopefully you checked it out that you had 2 here, 2 here, 2 here, 3 there. So that's our problem. 2 here, 2 here, 1, 2, 3 there. Okay, so we can see all the 2's are fine, but these 2 3's aren't. So if we just put another connection in there, then that changes to 4, and that changes to 4, and everything's even. And now we know we've Eulerized it, and we can go ahead and come up with a path. So how you chose to do that was completely up to you. I'll show you one way. Suppose I start at A here, and I go 1, and then 2, and then, yeah, I'm going to have to go 3, and then 4. Okay, can you see I have a problem here? I've chosen to go on my bridge before I've finished. That's not going to work. So let's try that over again. You don't want to use the bridge until the very end. So why don't I start here at the bottom and go around? And that way I will not use my bridge until I've done all the outside. That's going to work much better. So let's call this 1, this 2, this 3, and this 4. Okay, then I've done everything. Now I can use my bridge. Okay, so now I'm going to say 5, 6, 7, 8, and then back down 9. And we started and stopped at the same place. So we started at C, we went to D, and then to A, and then to B, and then to C again. Then we used our bridge to get to G, F, E, G, C. And this may not have been the way you did it, but as long as you used each path once and traversed every single edge, you're good. All right, so let's go back to our handout and read our last problem. Try to give an example of the graph that is described. If after several tries you cannot find the graph that is requested, explain why you think that it may be impossible to find. There may be more than one correct answer. Okay, so a connected graph. It has 4 vertices of degree 2. So this, I should have put some more space there. And 2 vertices of degree 3. So let's see, 4 vertices of degree 2, and then 2 vertices of degree 3. So I have to think of how to connect these to have 4 just be 2. Well, how about if I do like that? That's going to make 2. That's going to make 2. And how about these other edges? 2, like that. So 2 and 2. And then what if I just connect these maybe, or these? It doesn't really matter. So what do we have? 2, 2, 3, 3, 2, 2. So it's exactly what they said. 4 vertices of degree 2, 1, 2, 3, 4. 2 vertices of degree 3, 1, 2. So these are ones you kind of need to play around with. And I'm sure there are other pictures. Well, I know there are. We could have done a diagonal instead of here. All sorts of other ways to do it. This is just one possible way. Okay, no classwork number 18. This is it. We're done. This finishes all of our video lectures. I hope they worked out okay for you and you're able to learn. I missed you guys with this whole process, and I wish you the very best of luck in the future. If you continue on in school, good luck. If you're graduating and moving on, good luck. Hopefully I will get to see you again sometime. You were a great class. Bye-bye.